thanks to MBM for inviting me back, and thanks to JP Morgan for providing the room, and maybe, I don't know, maybe some of the beer and the pizzas at the back, and thanks to Martin for a really interesting talk. I feel like I might be sort of coming at some of the same issues, but from a slightly different direction, so I think it could be quite interesting for some conversation at the end. First of all, has anyone heard me talk about this before? 1, 2. Okay, we're not too bad. What I was thinking was, you know, if it gets to about 25%, a third, maybe I'll come up with another topic. I think at a certain point I was watching, a long time ago, I was watching a documentary, and I think it was Victoria Wood who they were interviewing, and she said at a certain point she realised that you could keep telling the same jokes because the audience would change each time and you could get away with it. So I'll keep asking that. So my topic tonight, the cargo cult of the South Seas, it's possibly going to go off at the deep end a little bit into something a little bit philosophical, so you have to bear with me at a certain point, but I hope that you'll all find it interesting and you'll see some of the parallels with some of the topics that Martin was talking about in his talk, and that probably a lot of us have been facing every day. So there's an overview of what I'm going to say. First of all, and I've rigged this around a few different ways when I've done it, I'm going to try and introduce myself and what my background is, which is a little bit different to Martin, although I feel like in some sense we're trying to get at the same issues and achieve the same stuff. The second part, the main body, I'm going to talk about the tale of the cargo cult of the South Seas. Have people heard about the cargo cult? A few nods, a few people putting hands up. Okay, there was an interesting property of it that when I did this talk of it, or a variation of it for the first time, I talked to somebody afterwards, and I said, wow, you know, you haven't heard of this before. I was really surprised, and we decided there was a property of it that it seems it's such an interesting, fascinating phenomenon, and the analogies are so useful. You always feel like everybody else has heard about it already, so you don't tell anybody. So I feel like I'm going to talk about it anyway for those people who haven't heard it before, which is sometimes more than you would expect. And then I'm going to finish off. I mean, it's a sort of data science talk, so I feel like, you know, we've got to have the sort of requisite, you know, discussion of what data science actually is, which I think is really an interesting topic. So the first part, who am I? So I come from a technical background. I have a degree in physics, which I got in Bristol. I then did a PhD in particle physics, where I sort of split my time between Bristol and CERN. And after that, I did another 4 years of physics, working for the University of California, San Diego, which was quite nice because living in California was nice, and living in Geneva was also nice. Although if any of you have got any you know, feelings that like it's a high-tech world in which, you know, everything is very flashy and futuristic, and you've seen Angels and Demons, right? Was the one where they came to CERN. So it is a photo I managed to dig out of looking to, well, it's not quite, my old office was the door next to that one. This was like a toilet with overflowing water that used to come out this way towards an electrical cabinet that you can't quite see there. That bit had fallen out of the ceiling, although you can see it was kind of cracking up. I mean, it was kind of like a shack built in the 70s. It wasn't exactly a sort of salubrious surrounding. So then in 2013, I moved to Freeagent, which is, people here heard of Freeagent? Yeah, a few nods. So I joined in 2013 as the first data scientist. And in 2013, we were about 40 people. So Freeagent, for those of you who haven't come across it, so we're a tech company, started in Edinburgh in 2007. Just last month, actually, we were acquired by RBS. So we're a operationally independent part of the RBS group now, although that's still, you know, the details are kind of still being worked out to some extent. We provide a service online to help micro businesses, so freelancers, limited companies of 1 to 2 employees typically, to basically get on with doing what they love, which is running their businesses, doing their work, and not worrying about the hassle of compliance and day-to-day bookkeeping. So my journey at Freeagent, so I initially actually joined a marketing team, which, coming from a background of many years of physics, was And I think I looked you up on LinkedIn, Martin. I think you started in marketing as well. So I went from physics to a marketing team, which was in a lot of ways a big sort of culture shock of not just the domain, but the kinds of people, how they approach things, totally different. So that was very interesting. I moved to engineering in about 2015, when we went from being like one data scientist to sort of trying to have a team. So we created an analytics team, which I have led since about 2015. And a lot of what I'm going to talk about now is sort of inspired by or influenced by, what I have, my musings in sort of trying to grow that team and thinking about the problems we've got as a business and how we approach them. What I've learned from most recently from doing a lot of hiring and talking to people who are looking to get into the field of data science, what they're looking for, what some of their misconceptions are, and how we be productive as an organization. So they were some of the themes that inspired me to talk about this in the first instance, and I'd like to share some of that with all of you tonight. So let's talk about the cargo cult of the South Seas, which I hope is as interesting as it sounds. So first of all, I should admit that the idea of this analogy was come up with by Richard Feynman in the 1970s. He's a fairly famous physicist, and who strangely only people in physics have generally heard of. People outside of physics is quite rare, I find, that they know who he is. But he was a very, very famous physicist, very big scientific educator, famous for a lot of other things as well. This isn't a talk about Feynman, so if you want, you can read about him on the internet. He gave this address to graduating students in Caltech in 1974. He was a professor of physics at the time at Caltech. And in this speech, he called it Some Remarks on Science, Pseudoscience, and Learning How to Not Fool Yourself. And it was in that speech that he introduced this concept of the cargo cult as an analogy for bad science and practices we can fall into that are dangerous in some way. So we'll start, I guess, with a bit of geography. So the South Seas we'll sort of define as this region labelled here as Melanesia. In my school, for some reason, we didn't really do geography beyond the age of about 14, so I'm not very good at it. But it's down here. And the phenomenon of the cargo cult has been observed actually for a very long time, since, trading between Europe, trading or other things between Europe and other parts of the world, started in earnest several hundred years ago. But what I'm going to focus on in particular right now is one of the most famous examples of the cargo cults that were observed in this part of the world during the Second World War. And the phenomenon of the cargo cult is something that happens when a technologically less advanced society comes into contact with more advanced industrial technology. And in some particular societies, that led to some really interesting behaviours that have a lot of parallels, I think, between, which Feynman was trying to draw out in his speech, between where we often go wrong, where we often do bad science. And so in the Second World War, soldiers from more technologically advanced nations came to these islands in the South Seas. There was some tactical importance of the islands in fighting against the Japanese, and they came to these islands and they built, runways, and they set up bases, and with them, came all of this cargo. So suddenly these people who've been isolated pretty much from the rest of the world since forever, suddenly coming into contact with people from far away who've just shown up, they've built a runway, and suddenly there are planes landing and there's all of this cargo being distributed. And there are some sort of sociological aspects about what was valued in these societies in terms of the importance of being the one who has all of the valuable goods, the one who is distributing the cargo, that made it quite, problematic for them to understand who are these people who are not like us, who are coming here with all of these goods. And at the same time, during this period, there was great, it could be seen as a positive time. There's all these great benefits, there's supplies, food and medicines and goods and fantastical machinery suddenly arriving out of nowhere. So after the war, when the tactical importance of the islands diminished and the soldiers left, the cargo stopped arriving. but the people who lived there wanted to relive that good time. They wanted the cargo to still come. So what did they do? Is imitate what they saw the soldiers doing. So, you know, this is a cargo cult aeroplane, for example, and it's easy to sort of look at it in amusement because you say, well, you know, to our eye, you know, a wooden aeroplane, it's got no engine, it's got no fuel, it's not going to fly. But in some sense, in their eyes, they were carrying out the rituals that they saw the soldiers doing. You know, they were doing the same things. It was a sort of worship of some of the behaviours that they'd seen in an attempt, as that was the important thing, to recreate the benefits of it. And so, you know, what's going on with this? There's a couple of, well, there's one very common explanation. There's another explanation I want to try and introduce because one of my colleagues at Freeagent recommended I read The Zen and the Art of Motorcycle Maintenance, which I enjoyed a lot. This is where we try and go off into my attempt at philosophy. One of the ideas that's introduced in that book is the relationship between a romantic understanding of the world and a classical understanding of the world. And I think that the cargo cult is a sort of example of this, that the islanders were taking a romantic understanding of what they saw. They'd observed behaviours happening and they'd observed the great results. So obviously, if we recreate that overall picture, that's what's going to happen. It doesn't matter too much about the details. But actually, unfortunately, in this case, it does matter a little bit about the details because they didn't have an idea of the global economy and manufacturing and how an aeroplane works. So obviously, despite their recreation of what they'd seen, the cargo didn't arrive, you know, it didn't work. And that's Feynman's point about, you know, when something is cargo culted, you're doing the behaviours, but you're not getting the benefits. It's not happening. And not to say that there's no place in the world for a romantic understanding of things versus a classical understanding. And indeed, in driving things forward, you often need that vision and that overall product vision to say, well, right, this is what we're going to do, you know, and have that picture of what it's going to look like when we're successful and let somebody else worry about the details. But at the same count, you've got to have somebody who's worrying about the details if you want to implement it and be successful. The other picture that people talk about when they talk about, you know, what does the cargo cult mean is sometimes, you know, the difference between correlation and causation, which is also an important thing to bring up in this environment. You know, it's a great XKCD on this one. I used to think correlation implied causation. Then I took a statistics class, now I don't. Sounds like the class helped. Well, maybe, you know. It's they were observing a thing, they did what looked like the same thing, you know, nothing happened. You know, there was a third variable that they didn't understand that was actually explaining what was happening. So that's another common explanation, and it's another thing we all need to be very aware of. So let's have some examples of some things that maybe we've all come across at some point. The first one, you know, cargo cult is often used in the field of computer science. So this was the best example I could find of a little comic for cargo cult programming. This is Git. People use version control, I guess. It tracks collaborative work on projects through a beautiful distributed graph theory tree model, which is very hard to say, actually. Cool, how do we use it? You know, very exciting. No idea, just memorize these shell commands, type them into sync up. If you get errors, save your work elsewhere, delete the project and download a fresh copy. You know, which to some extent works and people do it. But if you're doing that, you're not understanding really what the purpose of Git was. You're not really getting the true benefit you could be realizing if you actually understood how it worked. The next one, even worse, is cargo cult project management. Your competitors are faster because they have meetings where everyone has to stand up. Do people have stand-up meetings? Probably, yeah. We'll top that by having meetings where everyone does jumping jacks while I pelt them with office supplies. And look, it's working, obviously. The final example, and the worst of all, the most important one, you know, for this group, I think, is when you come on to cargo cult science. And I wanted to try to draw it a little bit towards data science. In Feynman's speech, he has lots of examples about advertising. I think there's lots of examples of cargo cult in advertising, but cargo cult science is, in some sense, the absolute worst. And we often see statements like this that say, this one taken from an article on Forbes, data preparation accounts for about 80% of the work of data scientists. You know, that sounds kind of realistic, right? I mean, we spend a lot of time munging data from, suspicious sources and fixing missing values and putting things in databases. And then it's usually accompanied by a statement about, data scientists not enjoying that part of the work, and something must be done that probably involves buying some very expensive product from some big consultancy, something to that effect. And on the face of it, in our sort of cargo cult picture, that looks right, because on the surface, we've got this, there was this bit at the end where we ran the algorithm, or we added something up or clicked a button and we got the answer, and then there was all this preparatory work that we'd spent months doing before that. So yeah, okay, it seems like, all right, well, there was 80% up to that point of the time. Maybe it was spent on munging data around before we got the answer. And that's the apparent, that's what we can see. That's what if somebody came into the office and asked people, what are you doing? And they said, well, we're putting data into this database or such like, that's what it might seem like. And at a certain point, they'll get the answer, and the business or the organization or whoever it is will say, great, it's the answer, all right, we're done. But the problem is, in reality, there's this extra bit that you have to do at the end, which is, checking it's right, comparing the answer with what you expected, validating that, proving that you're correct. And actually, that's the time-consuming bit that makes you go from cargo cult science to actual science. And if you talk to anyone who's ever worked on a big scientific project, probably what they'll tell you they spent their time doing really at the end was calculating uncertainties or cross-checking their model with collaborators, rather than just they got to the answer and they were done. So, of course, you can go too far. And really, to be good at science, you've got to know when to stop. You can refine and you can refine and refine and check and check and check. And at a certain level, it doesn't matter. So you've got to understand what's the required amount of precision and certainty in what you're doing almost before you start, lest you spend the next 3 years doing something that nobody's ever going to care about. So I'm going to talk a couple of examples of what I think we can do. The first part, to read from Feynman's speech again, he says the first principle is that you must not fool yourself, and you're the easiest person to fool. So you have to be very careful about that. And that's true. If you've convinced yourself of something that's wrong and then you've started selling it to others, it's only going to get worse. It all starts with you. You've got to be honest. And then he says, but being honest with yourself about things is very hard. That's much harder than it is to tell someone else the truth. So he says, after you've not fooled yourself, it's easy to not fool other scientists. You just have to be honest in a conventional way after that. So you just tell them, once you know what you believe is right and you're not fooling yourself, you just have to tell other people. It's easy. The first bit's the bit that's hard. So how you get around this actually is really hard. Not that I've spent a great deal of time looking, but it's really hard to find a reference for what the scientific method is in a credible scientific source. So I'm going to quote Zen and the Art of Motorcycle Maintenance again, and actually another thing in that book that's very interesting is the statement that, well, what is science is in itself not really a scientific question. So as somebody who's educated as a scientist, you don't actually spend that much time talking about what science is or what the purpose of science is. You spend time using science, but you often don't spend a lot of time thinking about what it means and why. So I mean, to go through a statement of the sort of classical scientific method, you have to start with a statement of the problem up front. You don't just go and start thrashing around without an idea of what you want to solve. You need to have an idea of the hypothesis, because what you're going to do is be very deliberate about it. With the hypothesis, you're going to design experiments that can verify against reality whether or not that's true. When you've got the results of the experiment predicted and you've got what you've observed, by comparing the two, you can decide what's right. You can decide if you're making wooden aeroplanes and the cargo's never going to arrive by asking yourself that question. So as individuals, by using the scientific method, we can avoid fooling ourselves. The really difficult thing, and I added this slide at the last minute so the picture's a little bit ambiguous. The last time I did this talk, I spoke to somebody about it and he told me, well, really the problem is having this conversation with people. And when I started in marketing, and I was still, Freeagent now is still small enough. I spend a lot of my time working with people in the business as well as technical people. And you can go to people who want to run a marketing campaign. Maybe they sent an email last month about some promotion and they noticed there were more subscribers on that day. So they say, well, we have to do it again, you know, and that's fine. That's like when in this picture, it's supposed to be a saintly person curing somebody of the plague. And you can say, well, this person, they recovered from a very grave illness, and what they happened to bump into this saintly person earlier in the day, maybe it was that, maybe that's a good cure for the plague. But unless we actually scientifically test that, all you'll be doing is spending your time repeating these cargo cult-like behaviours that are expending effort on something that could be better done on the thing that actually works. So I think I don't have a good answer for how to have this conversation with people, except that you've got to keep having it. You've got to tell people, if you don't put the time and effort into discovering what's really working, you're probably going to be spending your time doing things which do not. And wouldn't you rather be doing a thing, discovering a thing that's going to work, rather than continually doing a thing in the hope that if you change, you're going to lose that? As a sort of loss aversion thing going on maybe there. So the only real advice I have is be strong and keep having this conversation with people in the business. And where what Martin was talking about in terms of small experiments, you know, to show an immediate result, become really helpful in that, rather than saying, well, we're going to spend millions of pounds and I'll see you in a few years. So final part, real quick. So a lot of people talk about data science, and I mentioned that a lot of this talk was inspired by me trying to hire data scientists into the team. And what often comes up is that people, they see the machine learning parts, they see the big flashy, you know, pieces, they want to do that. But actually, what's it really all about? And I think David Robinson came to Edinburgh and he gave a talk at one of the other meetups that was really interesting. And he said on a blog post actually, that, you know, what data science is about insights, and machine learning is about predictions, and artificial intelligence is about actions. So if you have a clear idea of what those different pieces are and how they relate to each other, then I think you can really do something, rather than sort of coming up with these statements like you see quite often in a bit of explanatory sense. When you're fundraising, it's AI. When you're hiring, it's machine learning. When you're implementing, it's linear regression. And when you're debugging, it's printf. In other words, the closer you get to really doing something, the simpler what you're doing is likely to get. So I think you've got to be honest with yourself about that. A final slide. So in an attempt to sort of express some values, I kind of say why you don't need a PhD in physics to be a data scientist, because a lot of the qualities that make a good data scientist aren't purely found in physics. I know there's a few people in this room who probably have a PhD in physics, and in Freeagent certainly there's a bunch of us who are physicists doing this stuff, but it's not limited to that technical background, because in reality the solutions you come up with are more important than the tools you used, and the insights are more valuable than what data you had to analyze to get it. The communication and domain understanding is generally rarer than the technical skills these days. And I think you've got to beware the economics of commoditization, in the sense that now a lot of those more technical skills are becoming automated in terms of, you know, AWS, in terms of the machine learning products you can use there. So often you don't need to understand to such a degree the internals of how an algorithm works. You can simply purchase it. As a developer, you know, a software developer who's interested could spend a few days actually getting very far. So the real value is in understanding and communicating the problems. That's it. Any questions?
Questions for Dr. Dave?
Yeah. So you ended with this slide why you don't need a PhD in physics to be a data scientist. And before you had this this sort of reveal, it's 80% in, you know, data science is you know, is the preparatory work, and actually that's 80% of 50%, and the other 50% is the checking of it. And I'm wondering whether some aspect of that actually sort of comes from a kind of physics-focused academic background, because I guess in physics, if you're making claims about the nature of the universe, you don't want to get the wrong answer, and you've got these p-values that are orders of magnitude lower than would be accepted in any other discipline. So I'm wondering whether that's something you've had to kind of teach yourself out of.
Well, it is
that kind of precision.
It is my experience from physics that, you know, the level of precision required was much greater than what it is now. But that's not the only thing that's changed. When I was in physics, we were dealing with massive data sets. When I'm in Freeagent, you know, the data sets I'm dealing with are typically much smaller. So actually, you know, well, 95, you can talk about a 95% confidence interval on something, that's about 2 sigma, that'll come and go. If you're doing many experiments, you know, beware of multiple comparisons. So I think the principles still apply, even if the scale of what you're imposing to call something true is a little bit different. And you're right that a lot of that, which is skills that I think are very important, does come from what I've learned in physics. But we've also had a lot of success in hiring people from other backgrounds and teaching them that side of things. So I don't think, what I was trying, I guess, to make a bit the point of, is you don't necessarily need the background in physics. It is stuff that you can learn if you've got the communication skills and you've got the domain skills. And I think the fact that there are a lot of physicists doing data science is probably partly a product of the fact there are a lot of physicists in the world who are looking for job opportunities in other fields. Not so much that they're more suited for this work than anybody else. Yes.
I really enjoyed your presentation.
Thank you.
Marvelous. And Feynman's book was a great read.
Yeah.
Can you elaborate a little bit more on the last point you made about being wary of the commoditization of the kind of black box approach?
Yeah.
What's your experience of that? And
well, I
how
think.
Would you warn against it?
Yeah, I think the part I'm warning against. Oh, so the question was, you know, to elaborate a little bit further on the warning against commoditization of machine learning, what that means and why I should be warning against it. So I think my answer to that is that there are a lot of people at the moment who are studying, you know, to a small degree, to the extent you can over an undergraduate degree or a master's, machine learning and these kind of techniques. And they're coming out of the universities, a lot of them, with the impression that that's what the work's going to be. They'll maybe be sitting in a corner somewhere. They'll spend their entire day programming and optimizing machine learning models. At least in my organization, that's not what we really need from people to make an impact. A lot of that work of improving machine learning models is being done by droves of people working in Amazon and Google right now. So from a business point of view, a lot of businesses quite soon are going to be saying, can we just buy that in as a service? So then the value of you as a scientist who understands both how these algorithms work and the domain side of things, I think comes more out of being able to match those two up and make the connections and explain and see how that can be applied, more than that you're personally going to be optimizing particular algorithms. I mean, even when I was doing physics, we were essentially using off-the-shelf machine learning algorithms to do classification. We weren't spending our time dealing with the algorithms. We were spending our time understanding the domain of the problem, the physics of the problem. And personally, I think that's the interesting part. So I think therein lies partially the warning.
I just say I took the warning completely the wrong way around.
Okay. What was your interpretation?
Don't go near commoditized.
No. I think commoditization is what's coming. I think it's beware of commoditization from the point of view of a practitioner, that your own skills are being commoditized. You need to worry about the application in the business more than the precise optimization. And oftentimes, you're starting from a point of nothing, and a simple linear regression might be good enough for all intents and purposes. So don't go too far down that path before you've proved the value of something. Yeah.
You kind of made the point that in data science and machine learning, it could get to the point of almost where the context is more important. But you also kind of touched on how the preparation of data is so important. How do you see that working if almost machine learning can take over the preparation of data to an extent, and then that tying in with giving the context?
Yeah.
Because I think a lot of the time in the preparation you gain the context to explain the insight.
Yeah. I think I agree with. So the question was how does this fit, how does the commoditization argument fit in with what I said about the preparation taking up 80% of the time? How will that fit in? Will that part, as well as the provision of the context, be commoditized? Is that?
Yeah, providing the context. That's where a lot of the time you kind of get the explanation.
Yeah, yeah, and I actually think that you've got, I come at this from a traditional scientific point of view, where you collect the data yourself, you do the analysis yourself in some sense. I think if you can't sort of get in there over the whole process and be involved with the collection of the data and the analysis of it, you're not going to have the context to interpret the results, whether they come from a machine learning algorithm or a room full of temps or wherever exactly it came from. I think there's an example I read about, for example, where some algorithm was applied to some data about people going into banks and how they interacted. And they hadn't realised, the analysts, they'd been given this big blob of data, they hadn't realised in the way it had been collected, there was actually a lot of visits to the branches that were missing and weren't collected because the process involved paperwork and a lot of the forms were lost on some systematically biased basis. So unless you're really there throughout the whole process, it's very hard to make a good judgment about how to interpret the results. So I don't think that bit's I think that's the bit that's not going to go away, that will need people who go and work with people in the business, work with the people who want the answers and are collecting the data to be able to do. I think that's the bit that you can't really replace.
Yeah.
Cheers.
Well, just everybody a round of applause for Dave. Thank you, Martin, for that. You can see movement outside, so it looks as if the second round of pizzas have arrived. I'm not quite sure what the format is in terms of whether we can go out there, but there is a door. I would open it, I would go out, and I would eat all the pizzas.